Hi there. For this video, we'll be discussing what are parallel lines. So to answer that, parallel lines are lines that never intersects. So in here is an example that was plotted in a graphing calculator, wherein the first line is given by y equals x plus 1, and the second line is given by y equals x minus 1. Observe here that even if we extend these two lines out here, they would never intersect at some point. Now, so what is special about these lines? More importantly, how does this happen? So let's try to make some observations based on what we have. So we are given here two equations of lines, and observe that these lines are in their slope-intercept form. Now, based on the slope-intercept form, we know that this part out here represents the slope, while this part out here represents the y-intercept. So given that, let's make some observations. If we refer to this red line as the line 1, and this second line as the line 2, then observe that their slopes are equal. So we have here the slope of line 1 is equal to the slope of line 2. They're both equal to 1. How about their y-intercepts? Observe that the y-intercept for the first one is 1, and the y-intercept for the next one is -1. So we have the y-intercept of the first line is not equal to the y-intercept of the second line. Since we have 1 is not equal to -1. Now we will be generalizing this idea in the next remark. So as a remark, we say that two lines, say L1 and L2, are parallel if their slopes are equal and their y-intercepts are not equal. So to explain this much better, we can write L1 or the line 1 as y equals m sub 1 x plus b sub 1, and L2 as y equals m sub 2 x plus b sub 2. So these two lines are parallel if m sub 1 is equal to m sub 2, it's written in here, and if b sub 1 and b sub 2 are not equal. Let's use this graphical representation to demonstrate it. First, suppose that what if m sub 1 is not equal to m sub 2? This means that the inclination or the steepness of one of the lines is different from the other one. So if we have this first line, then it might be slanted quite like this if they are not equal. Although it's not evident here, at some point, these two lines will converge out here, or they will intersect. So, they won't be parallel. If we do it on the other way around, say if it's slightly slanted like this, then at some point, these two lines will intersect out here. So they are not parallel. So it is really important that the slopes of the two lines are equal. Now what if m sub 1 is equal to m sub 2, but the y-intercepts are equal? If they are equal, by definition of y-intercept, then these two lines intersect the y-axis at the same point. That means that L sub 2, if they are equal, then it might move at this point to match the same y-intercept. And what can we see out here? The two lines are now on the same part of the graph, or the Cartesian plane. Therefore, what happens is that all points of L sub 2 intersects L sub 1, so they are not parallel. This happens because L sub 1 and L sub 2 become the same line. So if they are the same line, they are not parallel. So the condition that they are not equal is really important. Now let's try some examples applying this new knowledge that we have. So for this first example, we are tasked to determine if these lines are parallel. The lines are x minus 2y equals 7 and negative x plus 2y equals 3. Now feel free to pause this video so you can try to solve this one on your own. Good, let's start. So to determine if these lines are parallel, a good tip is to first convert these lines into their slope-intercept form. So for this first one, we have x minus 2y equals 7. To convert this to slope-intercept form, what we first do is we can subtract x both sides to isolate y on one side. This will give us negative 2y equals negative x plus 7. Then we divide negative 2 on both sides of the equation to obtain y equals 1/2 x minus 7 over 2. We do the same for the second equation. So we have here negative x plus 2y equals 3. What we do is we add x on both sides of the equation to isolate y again on one side. This will give us 2y equals x plus 3. Then we divide to both sides to obtain y equals 1/2 x plus 3 over 2. Now let's try to observe. Since we know that we have converted the equations to their slope-intercept form, then these out here represents the slope. Since they are equal, then we have a valid we got the first property correct for parallel lines. Since the slope of the first line is equal to the slope of the second line. Next, if we try to observe the y-intercept, observe that they are not equal. So we got the second condition for parallel lines correctly. Therefore, we can conclude that these two lines are parallel. Indeed, if we try to graph this in a graphing calculator, as you can see, these two lines are indeed parallel. If we try to extend these lines out here, note that these lines are straight, so just ignore the imperfection of the lines that I have drawn, but they would never intersect. Now that we know how to determine if an equation of a line is parallel, we now try to answer or show a nice application of it through the next example. In this one, we are tasked to determine the equation of the line parallel to 2y minus 4x equals -1, passing through -1, -3. So feel free to pause the video if you have an idea on how to try this. Good, let's start. So in here, our goal is to find an equation of a line such that this line is parallel to this and it passes through this one. So first, note that we know that parallel lines have equal slopes. So we can try to discover or find that first using this one. To do this, we convert 2y minus 4x equals -1 to its slope-intercept form. So we have here 2y minus 4x equals -1. We can add 4x both sides to obtain 2y equals 4x minus 1. Afterwards, we divide 2 on both sides of the equation to get y equals 2x minus 1/2. Upon obtaining this, again, note that what we need is the slope. And since this is already in the slope-intercept form, we know that this out here is the slope of the line. So we know that the equation of the line parallel to the given equation must also have a slope of 2. So far, we know that our equation is of the form y equals 2x plus b, if this is in slope-intercept form. Our only problem is finding this y-intercept. Fortunately, we are given a point out here to find it. So what we do is we simply plug in the given point to this one. So we have this to be the x value and this to be the y. So we'll have here -3 equals 2 times -1 plus b. This simplifies to -3 equals -2 plus b. Lastly, we add to both sides to obtain b equals -1. And this out here is our slope our intercept. Therefore, using this out here, plugging this into this one, we obtain an equation of line parallel to the given equation. This is given by y equals 2x minus 1. And this out here is our final answer. To prove that this is correct, here's a sample graph or sample illustration given this one. So this one is the given equation, and this one is our obtained equation. So as you can see, these two lines are indeed parallel. So that is a nice application on parallel lines, since given one of the equations, we can determine its parallel line or a line parallel to it just by having or knowing one point on it. As an exercise, you may like to work on this example. So in here, we are tasked to find the equation of the line parallel to 12x plus 15y. Oops, there should be an equal 0 out here. Equal 0, passing to the point 4, 0. So to answer this, you simply follow the same process in the second example. And take note that our goal is to find an equation. So that's it. Feel free to comment down below if you have a solution or an answer to this item out here. So yeah, I hope you enjoyed this one, and that is all for this video.